No.
What about others? No doubt. Done. Easy questions.
Yes, sir. Yes, sir.
Okay, so we talked about many electrode, metal, metal electrode, metal, metal ion electrode, and gas electrode, and how to, like, when we take it as anode, what is the procedure? When we take it as cathode, what is the procedure? Okay, so type of electrode we talked about, right? Type of electrodes we talked about. Today, two more type of electrodes are there, and then we'll start electrolysis. So this is known as calomel electrode. Calomel electrode. Okay. Now, what is calomel electrode? This is an electrode. Okay, this is made up of glass. Okay, this is made up of glass, and this side, this here you can see that it is there is a port where you can put any gaseous substance or something, and it made up of mercury. Okay, Hg, and here it is Hg2Cl2. Okay, and this line, if you can see or not, you can see the photo here. Can you see the photo?
Yes, sir.
Yeah, there is a line is there. This is nothing but platinum wire. Okay, this is nothing but platinum wire. I can show you in detail. See, this is actually in detail. You can see. See, this is electrical wire. It will come outside. This is platinum wire, and there is a paste of silver and HgCl2 with saturated KCl. Okay, now silver is the electrode, Hg2Cl2 is the electrolyte, act as electrolyte, and KCl is, you know that we use KCl as a salt bridge. Okay, and outside this is made up of, like, this is, you can think that this is a glass. Actually, this is a ceramic glass. Okay, very hard glass, it will not break. Okay, and there is saturated KCl is there. Understood? So this is called calomel electrode. Okay, now why we use calomel electrode? Because see, more efficiency we need, more, because mercury is less stable than mercury have, it is not zero. For hydrogen electrode we are using, that is zero, right? But for mercury it is not zero, and hydrogen is a gas. For that we cannot hold it. So that's why just hydrogen, after that mercury is there, after that copper, and then mercury is there. So that's why we are using mercury. Okay, now so question, what kind of question they will ask, that in calomel electrode, what is the electrode, what electrode is there? That is mercury. Okay, platinum in mercury, clear? And what is the electrolyte we are using? Hg2Cl2, clear or not?
Yes, sir.
Next, if you let's suppose, if you use this as anode, if you use this as anode, then what will happen? Simply, what is the oxidation state? Tell me, what is the oxidation state of Hg, mercury in Hg2Cl2? What is the oxidation state?
Plus, plus two.
Oxidation state of mercury in Hg2Cl2.
Plus, sir.
Plus 2, Hg2Cl2. Hg2Cl2
Plus.
plus 1. Okay,
Oh, yeah,
and
plus one,
mercury
plus.
oxidation state 0. So anode means oxidation. So mercury to Hg to 2 plus, right? Yes or no? 2
Yes.
Hg plus mercury plus 2 electron, right? This will happen. Now, now listen. This Hg to 2 plus, this Hg to 2 plus, because we are using KCl now. So this Hg to 2 plus will react with Cl minus and become Hg to Cl2. Okay, so overall anode reaction, what is the overall anode reaction? Anode reaction is mercury. What is the state of mercury liquid? Okay, and it react with to chlorine, that is in aqueous KCl solution, and then it will make Hg2Cl2, that is also aqueous, plus 2 electron. How to write when you are using this in anode? See, platinum is the electrode, then mercury is there, then Hg, mercury become Hg2Cl2, is also liquid, and then salt bridge. Clear or not?
Yes, sir.
Understood this thing? Okay. Next, if you use this as cathode, if you use this as cathode, then then what will form? Same thing, same reaction, just reverse. That means Hg2Cl2 will break into H2 Hg2Cl2 will break into 2 Hg 2 plus. Okay, sorry, 2 Hg plus, actually Hg2Cl2 will break into 2 Hg plus 2 Cl minus. This 2Hg plus will get 2 electron and become 2H. Understood? So final equation is Hg2Cl2 plus 2 electron giving Hg plus 2Cl minus. So how to write that? Solid bridge is there, then chlorine minus aqueous and Hg2Cl2 liquid, then Hg liquid, and then platinum. Clear this thing? Yes or no? Understood what is calomel electrode? They will ask like that. What is calomel electrode? What is the anode reaction or anode representation, cathode representation? Okay. Or they can ask that anode calomel electrode with zinc. So then you have to find out an E naught value given. Okay. Then you have to find out which one you have to use. Already you know that by checking the E naught value, that we can tell that which one will be anode and which one will be cathode. Yes or no?
Yes, sir.
How to do that? Tell anyone how to do that.
Low inode value anode.
Low E naught value will be anode.
Anode.
And high E naught value. Low means negative side also low. Okay.
Yes, sir.
So low E naught value means anode and high E naught value is cathode, right? Very good. So from that you can understood that what you have to use cathode and anode. Next type of electrode is known as quinhydrin electrode. Okay. Quinhydron actually. Quinhydron electrode. What is quinhydron? I'll come into it. Okay, so this looking like this is the electrode look like. Okay, so here one conducting wire is there. This actually upside down. This electrode is looking upside down. Actually electrode is here. Okay, and this is why you can hold. Okay, and you can press here, then the reading will come different. Okay, so this attached with a ammeter and all the things attached together. Inside this electrode is there. When you press conducting wire, so then what happened? This there inside is the graphite is there and quinhydron mixture is there. Okay, then there is a reaction and it will conduct electricity. Now, first of all, can you tell me one thing? What is this? This is benzene.
Benzene.
If I put OH group here, do you know what is the name of this compound? Ah, very good. So the name of this compound is called phenol. Okay. Now, if instead of one OH group, if I put OH group in para position, this is para position. So two OH group in para position, this is known as hydroquinone. This is known as hydroquinone. Okay, hydroquinone, also known as quinol, hydroquinone or quinol. Now, if I oxidize it, simply if I do oxidation, then what will happen? Simply removal of hydrogen. So this hydrogen will remove, this hydrogen will remove. And if oxygen, you know, it make two more. So it will make double bond here, it will make double bond. So how it will look like? It will look like this. Later on in this year also, we'll do this reaction. What are the oxidation agent and how it done? We'll see. Okay, so this is hydroquinone. And this is known as quinone. Quinone. Okay. Hello. This is known as quinone. Quinone denoted as Q. And hydroquinone denoted as then Q plus 2 hydrogens are there, right? Yes or no? That's why name is hydroquinone. Clear? Clear or no? So what will be the reaction in anode then? If you use this as anode, okay, what will be the reaction? See, oxidation, right? So QH2 will become Q, yes or no, plus 2H plus 2 electron. Clear? Yes or no? Understood this thing? This question very important. In hydroquinone electrode, what is the reaction? They will ask. Okay, so this is the reaction. When KOH2, this is aqueous solution, and this is also aqueous. All are actually liquid. Hydroquinone also liquid, quinone also liquid. Okay, so what is the N value here? What is the number of electron here passing? 2 electron. Okay, how to represent? I already told that platinum here we are using as an electrode, and quinhydrin electrode, aqueous state, it will be in aqueous state, and H plus and quinhydrin electrode, quinone aqueous state, then solid bridge like this. Clear? This is as anode. Oxidation happen. Now at cathode, what will happen? Reverse. As Cathode, what will happen? Reverse, that this will come this side. Okay, reduction. Okay, so simply Q plus 2H plus 2 electron giving queen hydrogen atoms. Okay, so for this you can write there is salt bridge, then Q H plus dot QH2 and double single platinum solid. Understood? Yes or no?
Yes, sir.
So two type of electrode today we learn. One is calomel electrode, one is queen hydrogen electrode. See, many reactions, many type of electricity calculations and all. We should not only like depend on hydrogen electron. That's why we use different type of electron. Okay, and this this like queen hydrogen electrode. These are new and advanced type of electrodes are there. Clear? Next, understood till now? Any doubt?
No, sir.
Okay. Next is called electrolysis. So till now we learned about about chemical cell, okay, or galvanic cell. That means the reaction, reaction giving electricity. Now we are seeing electricity will do reaction, non-spontaneous reaction, like whatever reaction cannot be done. Okay, that kind of reaction we can generate by electricity. Okay, so we will learn electrolysis and electrolytic cell. Electrolysis and electrolytic cell. So first of all, what is electrolysis? Electrolysis means it is the process using an electric current to carry out an otherwise non-spontaneous reaction. Okay. So what is electrolysis? That a process of it is a process of using electric current to carry out an alternate hello
Yes, sir.
carry out not alternate carry out a non-spontaneous reaction. Okay, or or one more thing you can say, that by electrolysis what we can do, whatever ion is charged, let's suppose NaCl is there, after breaking it will become Na plus Cl minus. Again we wanted to make them together. Okay, then we have to use electrolysis. So electrolysis means of the process of discharging ions from its from its electrolytes. Clear? Okay.
Yes, sir.
Understood? Yes or no?
Yes, sir.
Okay. Now, so in electrochemical cell or galvanic cell, what we learned, that there is a two half cell is there. One is anode, one is cathode. In anode, oxidation is there. Anode is negatively charged. Cathode is positively charged. Reduction is there. Many things. But in this case, what happened? We are using only one cell. Okay, we are using only one half cell. Here we are using only one half cell. In that half cell, what we are doing? We are putting two electrodes. In that half cell, we are putting two electrodes. Okay. Yes. Okay. We are putting two electrodes. Now they are connected with a battery outside with a battery. Okay. Now in this solution, Understood this thing, very important. In this solution, some electrolyte is there. Let's suppose A plus and B minus is there. A plus and B minus is there. So when I turn on the electricity from the outside, when I turn on the electricity, we see where we can see that all the A plus ions, all the A plus ions coming this side, all the A plus ions coming this side, and all the B minus ion coming this side. Okay, all the B minus ion coming this side. Now tell me, who will be attracted to like positive charge will attracted to which electrode? Positive electrode or negative electrode?
The negative electrode.
Negative electrode. So from here we can say that this is negative electrode. A negative charge attracted to which side? That is positive electrode. Yes or no?
Yes, sir.
Okay. Now listen. This B minus, when it came, B minus came to negative side, and it is B minus came to negative side, and it is giving one electron. It is giving one electron and become B. Clear? B minus giving one electron, removed one electron and become B, neutral. Okay. So tell me, this is reduction or oxidation? Tell me, this is reduction or oxidation? Oxidation. Now tell me, where oxidation happened? Anode or cathode? Anode. Okay. So in this electrolytic cell, anode is positively charged. Okay, but oxidation happened. So remember, anode can be positive or negative. Okay, doesn't matter it is positive or negative. But anode means there should be oxidation. Now A plus came this side. So this electron was removed by B minus. So this A plus will get that electron from this electrode, and finally it will give A. Finally it will give A. So this is reduction, and reduction happen in cathode. Clear or not?
Yes, sir.
Okay. Achha, how much potential we give? This is, I'm telling you, arbitrary 5 volt. This much potential. This potential is known as discharge potential. Discharge potential. Clear? That how much potential you will give? That is known as discharge potential. Clear or not?
Yes.
Okay, now simply let's suppose A plus B minus, forget about A plus B minus. Let's suppose we are taking NaCl. So NaCl will be Na plus and Cl minus. Yes or no? Now NaCl, if I take NaCl, okay. Hello, am I audible?
Yes,
Okay, if I take NaCl, I am coming into it. So cathode reaction and anode reduction reaction, you understood, right? Yes or no?
yes, sir.
Now, one example we will take, you will understand. Let's suppose we are doing electrolysis of molten NaCl. Electrolysis of molten NaCl using platinum electrode. Okay, molten NaCl using platinum electrode. So what we know, NaCl already in electrolyte it is dissociated into Na plus Cl minus, right? Now tell me, what will be the reaction in anode? What will be the reaction in anode? Tell me, what will be the reaction in anode? Oxidation. What reaction? In this electrode, in this electrolysis, what will be the reaction?
NaCl to Na plus.
That is already there. Array, this is the solution. Already Na plus Cl minus is there. So in the anode side, what will be the reaction? Anode side, what will happen? Cl minus will become Cl. Yes or no?
Oh, yes, sir.
Okay. Now Cl is stable. No, Cl is an atom. So Cl is stable in what state? Gaseous state. So Cl minus will become half Cl plus 1 electron. Clear or not?
Yes, sir.
So in anode side, what gas will form? Which gas we will get? Chlorine gas. So if you take NaCl and you are doing electricity, put electricity both side, what you will say? One side chlorine gas is coming. Okay, so which side chlorine gas will come? Anode side. Okay, now cathode side reaction, what will be the cathode side reaction will be? So cathode side reaction, what will be? Na plus already there, and Na plus will take one electron and will become Na. Now Na also not stable. Why not stable? Because you are taking NaCl aqueous solution. So Na will react with water. Yes or no? So
Yes, sir.
when Na will react with water, what you will get? NaOH plus H2 gas. Yes or no?
Yes, sir.
So in cathode side, what gas you will get? Hydrogen gas. Okay, and NaOH also you will get. NaOH gas you will not get, but NaOH also you will get. Clear? This question can be asked that molten NaCl here electrolysis. What is the cathode side gas? Will which side cathode? Which side hydrogen gas will form and which side chlorine gas will form, and why? Explain with reaction. Clear or not?
Yes, sir.
Okay. Remember one thing. Remember one thing very important. Here chlorine is there. If anion is chlorine, fluorine, bromine, iodine there, then formation will be X2, means Cl2, F2, Br2, I2 gas at anode. Okay. But apart from this, any other anion is there, any other, then oxygen gas will form in anode. Understood?
Yes, sir.
Now you will tell sir why? Because this have more oxidation potential. This four have more oxidation potential than oxygen. Then after that, all the other element will come. For example, if I take, let's suppose electrolysis of water. Let's suppose we are doing electrolysis of water. Very important. This is electrolysis of water. So if you do electrolysis of water, let's suppose you are taking one beaker. You are taking one beaker, and in that beaker you are adding some electrode and add it. Okay, so for electrolysis of water, we actually need 6 volt, 6 volt potential difference. Okay, now see, let's suppose this is anode, this side anode, and this side cathode. Now, water, remember, water is a weak electrolyte, yes or no? Water is a weak electrolyte, means it will not break, right? Yes or no? Water will break?
Yes.
It will not break. So, to enhance this reaction, from the outside, we are adding Na2SO4, sodium sulfate. Okay. From the outside, we are adding Na2SO4. Now, in Na2SO4, what is there? Now, in this solution, what is there? Water is there and Na2SO4 is there. Clear? Now, listen. Na plus ion there, water, SO4 2 minus ion there, and water is there. If you check the reduction potential of Na plus, minus 2.71 volt, and this because SO4 2 minus is an anion, I'm not writing the reduction potential. So water reduction potential is 0.83 volt, and oxidation potential Na plus I'm not writing because it is not a good oxidizing agent. Also oxidation potential we don't have, and this is 2 volt, and water oxidation potential minus 1.23 volt. Now understood one thing. Hello. Now understood
Yes, sir.
one thing. Na plus is there. So water will react with Na plus and give hydrogen gas. Okay. Okay. Clear? Hello?
Yes, sir.
Listen.
Yes.
Na plus having more negative value. That's why Na plus can replace this hydrogen. Clear? But SO4 2 minus have positive value and it is negative value. It cannot replace oxygen. Clear? So that's why instead of replacing oxygen, see, this is another anion. So in the cathode side, which gas will form? Tell me. In the cathode side, which gas will form? Tell. Well, write the reaction. Write the reaction, you will understand. Anode side, at anode. So I took water. I took water. Tell me, water after oxidation, what will be the product? If you oxidize water, what can be the product? What is the possible product? Any guess?
H2O2.
H2O2. Eh? Oxidation means what? Removal of hydrogen. So hydrogen remove. So what will remain? Oxygen. Now oxygen cannot remain single, so O2 will be there. Yes or no? So water liquid from O2 we will get, plus H plus ion we will get, and electron will get. Now if you balance, this will be 2, this will be there will be nothing, 4H plus 4 electron. Clear or not? Tell.
Yes, sir.
So at anode side, oxygen gas will form. In this which gas formed? Chlorine. Here also chance of sulfur dioxide or SO2 SO3 gas formation. But why not forming? Because this oxidation potential or reduction potential is below or above that. That's why not forming. But in cathode, same as that reaction. Cathode, what will happen? Cathode is there. Cathode water is there. Okay, and it will take 2 electron. Take this 2 electron or 4 electron, whatever. Okay, 2 electron, and it will give hydrogen gas plus 2OH minus. Clear or not? Tell.
Yes, sir.
Okay. So what you have to do to balance this? You have to multiply the 2 and all, whatever. Okay. So if you electrolyze water, what you will get at anode side? What you will get? You will get oxygen, and at cathode side, what you will get? Hydrogen. Clear?
Yes.
Similarly, if I ask you,
So,
tell.
so reduction potential is negative of oxidation potential.
Uh,
So how can H2O minus 0.83 and oxygen potential is minus
sorry.
1.3?
This will be plus. Correct. Plus. No. It will be minus 1.2. Actually, if you check, two reactions are completely different. Yes or no? Can you see here? This is the oxidation reaction, and this is the reduction reaction. Yes or no?
Yes.
Tell me.
Yes, sir.
This is oxidation reaction. This is the reduction reaction. Two reactions are completely different. Yes or no? So that's why reduction potential and oxidation potential different. Okay. Overall cell. What is the overall E naught value? Tell me. What is the overall E naught value? Tell. E naught value for this cell electrolysis of water. What is the E naught value? Tell.
Minus 0.4.
Wrong.
Sorry.
Cathode minus anode. Yes or
Yes,
no?
sir.
So cathode is minus 0.83. Yes or no? Minus.
Plus 0.4.
Correct. Okay, minus or minus 1.23. Minus of minus 1.23. Clear? Yes or no?
Yes, yes.
So that will become minus 2.06 volt. Array, if E naught is minus, that's why it is a non-spontaneous reaction. That's why we have to give electricity. Clear?
Yes, sir.
That you need to understood. See, mathematics, whatever done is chemistry, you should need to understood. On the base of chemistry concept, you can tell anything. Okay, concept should be clear. Value whatever come, the value here why negative came, because this is non-spontaneous reaction. H2 water to oxygen and hydrogen. This is non-spontaneous. If this is spontaneous, then this pollution is will be not there. Okay, from the sea water they will make oxygen. Clear? No issue about that. So this is non-spontaneous reaction. Clear?
Yes, sir.
Next, tell me, you only tell that if you do electrolysis of copper sulfate, electrolysis of copper sulfate, anode what will form, and cathode side what will form? Tell me.
Anode is oxygen.
Very good. Anode side oxygen will form. Cathode side tell.
Hydrogen.
Hydrogen and So hydrogen and copper will form. Simple. Yes or no?
Yes.
Anode side.
Sir,
Tell.
sir, where is the hydrogen coming from?
Arey, water is there na.
Oh, okay, sir. Electrolyte.
Copper solution, aqueous solution. Okay. Water is there. Simply. Yes or no? Understood?
Yes, sir.
Yes, sir.
So can you write down the reactions for anode and cathode?
Anode simple. That simple reaction, that water to oxygen plus 4H plus 4 electron. Yes or no? This is anode reaction. Cathode reaction is simply water plus the like this. You can go water plus 2 electron will give hydrogen plus OH minus. Okay, hydrogen plus OH minus. Now here in the cathode side also copper 2 plus is there. Copper 2 plus will become copper, and anode side also SO4 2 minus is there. It is making SO2, but SO2 gas will not form. Okay, clear, because it is not getting this electron and all. Okay or not?
Oh,
Hello.
okay, sir. Okay, sir.
Okay. Next, next. Now, till now we are talking about, sir, this side. This is forming. This is depositing. See what will happen. Like copper sulfate, copper will deposit this side. Yes or no? Copper will deposit this side. Okay. Or if NaOH formation is there, NaOH form NaCl, NaOH form formation is there. So NaOH will form this side. Yes or no? Sorry, negative side will form. NaOH form will be this side. Now the question is how much amount do you get? Like oxygen is forming, hydrogen forming, how much amount do you will get? Okay, that how to know? Clear that this gas is evolving. How much gas will evolve? This hydrogen gas evolving. How much gas evolving? Or oxygen gas evolving? How much gas evolving? So to determine that, one scientist was there. His name is Faraday. Okay, he gives two laws to determine this this to determine the amount of substance liberated or deposited in the electrode. Okay, so Faraday gives his law for what? To determine amount of substance liberated or deposited in electrode. Okay, so to determine the amount of substance liberated or deposited in electrode, okay, we can determine by Faraday's law. Now two laws are there. First law is telling, remember in exam they can ask the state to Faraday's law and write the equation and explain. Okay, so Faraday told that the amount of substance or gas, whatever, substance liberated or deposited or deposited is directly proportional to amount of charge passed through electrolyte. Amount of charge passed through electrolyte. Now we took the electrolyte, yes or no? In that electrolyte, how much charge we are passing, that much will be directly, like directly proportional to the amount. Like more charge you give, more amount of substance will form. So let's suppose W is the amount of substance liberated. It is directly proportional to the Q. Q means, what is Q? Q is charge. How much charge you are providing. Okay. Now you in physics you learn that charge is equals to current into time. Yes or no? Current multiplied with time. I think in physics you learn this. So Q is equals to, we can write I into T. So W is directly proportional to I into T. Now if you remove the proportionality sign, what you will get? You will get W is equals to Z into Q, or W is equals to Z into I into small t. Okay. Okay. So I'm writing one by one. What is that? That W is amount of substance liberated or deposited. Amount of substance liberated or deposited. What is Q? Q is charge you passed, how much charge you passed. How to calculate how much charge passed? That current, okay, current value, how much current you are providing, that is in ampere. Okay, and T, T is time, that will be in second, minute, whatever. Okay, and what is Z? Z is a constant known as electrochemical equivalence, known as electrochemical equivalence. Understood this thing? Yes or no? Tell. Yes or no? Tell. So this is the formula. First law formula: W equal to Z into I into T. No doubt.
No, sir.
Hmm? Clear?
Yes, sir.
Okay. So just give me a second. I'm giving a question. Hmm. Okay. As before going to a question, understood what is Z? Okay. What is Z? So Z is equals to, what can I write? W by I into T. Yes or no? What is Z? Z is equals to W by I into T, or W by Q. W by Q. Now, what is Q unit? Coulomb. Acha, if Q is equals to 1 coulomb, then Z is equals to W. Yes or no? So let's suppose you have an electrolyte. Okay, you made a electrochemical cell and whatever electrolyte, and you put electrode and connect it with a wire outside. Connect it with a wire outside. If you pass 1 coulomb charge, how much amount deposited? That is known as Z. Okay, that is known as Z, also known as Faraday's constant, also known as Faraday's constant also. Okay. Okay, so Z also known as Faraday's constant. Also we can write that Z is equals to E by F. Z is equals to E by F. What is E? E is nothing but charge. Okay, that sorry, E is called equivalent weight of any electrode or compound. Equivalent weight. For example, if you are talking about oxygen, then the oxygen equivalent weight is 8. In grade 11, you learn this thing, equivalent weight, redox reaction, N factor. This thing you know, N factor, N factor, N factor. How can I tell? Acha, what is equivalent weight? Remember, equivalent weight is equals to molecular weight by valence. Clear? Now understood? So if I talk about oxygen, O, not O2. Oxygen weight is 16 and valency 2. So equivalent weight is 8. Similarly, chlorine valency will be 1. So equivalent weight is 35.5. Okay. So like that you can calculate. So if I ask you what is the equivalent weight of magnesium, so it will be 24 by 2. So 12. Okay, like that. So Z is equals to equivalent weight by F or W by Q. Okay, what is the F? F is nothing but 96500 coulomb per mole. 965 96500 coulomb per mole. What is this? This is nothing but 1 mole electron have how many charge, how much charge? That is known as F. F is known as Faraday's constant. Okay, F is known as Faraday constant. Understood this thing? Yes or no? Tell.
Yes, sir.
Okay, so what is Z? Z is a equivalent. Z is a electrochemical equivalence. Okay, what is Z? Z means when 1 coulomb charge pass through an electrolyte, how much amount of substance liberated or deposited? That is known as Z. How to calculate? Either you can go with E by F or W by Q. Okay. Now I am giving a question. Let's see who can tell you. So question is, an aqueous solution of copper sulfate was electrolyzed by platinum electrode. Okay, by a current using a current of using a current of 0.1287 Armstrong for 50 minutes. Okay, 0.1287 Armstrong for 50 minutes. First, you have to write the cathodic equation. Write the cathodic equation. Second, you have to calculate. One is electric charge passed during, like Q. You have to calculate Q, and mass of copper deposited. Okay. Now I'll not write copper deposit where, cathode or anode. That you need to find out. Mass of copper deposited. Okay. Given that fluorine 1 Faraday is equals to 96500 coulomb per mole. Okay. Go ahead. Giving you 5 minutes. Your time starts. Understood the question, what to do or not? Hello? Understood the question, what to do or not?
Slightly, sir.
Okay. The first question you understood. Okay. That copper sulfate, we are doing electrolysis, and then all the values given, just you need to find out Q and how much copper deposited. Okay. Go ahead.
Yes.
Okay. So within 5 minutes, you just do it and send it in the group. Let's see who can send as fast. Or you can tell also.
it Armstrong or Ampere? Sir?
Ampere. Current electricity not done in your 12th in physics.
No, sir. What you are saying, you said Armstrong.
Current electricity not done.
No one is done.
Okay, go ahead.
So
Hmm.
the charge is 36.1 coulomb
3,
and then 86.1 coulomb.
1 coulomb. Good. Next.
The mass is 0.1270 gram.
Correct. Very good. So what is the cathodic equation then? Cathodic equation is oxidation of copper. So copper 2 plus 2 electron will give copper.
Plus U.
Yes or no? Clear or not? So from here you can see copper valence is 2. Yes or no? So Z value is equals to E by F. Okay. Z value is equals to E by F. So we'll calculate one by one. First calculate Q. What is Q? Q equal to I into T. Yes or no? So I value given 0.1287 ampere multiplied with T. How much T? T is 50 minutes. But remember, in second we have to take, right? In second we have to take. So 50 minutes means 50 into 60. So 3000 seconds. So if you calculate all of them, you will get 386.1 coulomb. Now, how much mass copper deposited? So M is equals to Z into I into T. Now Z is equals to E by F into I into T. Now what is E? E means equivalent mass. Equivalent mass of copper means what? 63.5 divided by 2. Yes or no?
Yes.
Understood? Multiplied with F value. Remember F value very important for electrolytic cell and all. That is 96500. Easy to remember 96500. Okay. Multiplied with 386.1. So if you calculate this, you will get 0.127 gram. Okay. Clear or not?
Yes, sir.
Okay. So units also you can measure. See, this unit is gram per mole. This unit is ampere per second. Okay. This unit is ampere per second. No, ampere second. And this unit, this 2 is in factor. Okay. No issue. This is coulomb. Sorry, ampere per second is equals to also we know equal to coulomb. And this is coulomb per mole. So mole inverse cut, coulomb cut, finally we will get gram. Okay, so my answer is correct. Clear? So that is how you can check out. Okay, clear or not? Hello.
Yes.
Okay, so now listen. In the electrolysis, what is the product form? In the electrolysis, what is the product form? Okay, that how to remember? That like what is the product form, how to remember? I told you already, a gaseous form, but sometimes it will change. Okay, depends on factors. So factors affecting electrolysis. Okay, factor affecting product formed during electrolysis. During electrolysis. Now, what factor? First factor is what electrode you are using. Yes or no? Nature of the material. Nature of the material being electrolyzed. Yes or no? Like if you change the electrolyte or electrode, then the product you will get that will change. Simple. Yes or no?
Yes, sir.
Okay. Now, second point is type of electrode. Remember this thing very important. Type of electrode. Remember, if you are using platinum or silver, these electrodes, these are inert electrode, right? Inert electrode. When you are using this, no change, nothing, not a change will be there. Okay, but if your electrode is reactive, for example, copper or zinc, they will react with oxygen. They will react with, for example, you are taking carbon. Very important. Carbon. Carbon is not inert electrode. So when carbon you are taking, carbon will react with oxygen and become carbon dioxide. So when you are using carbon, instead of getting oxygen, you are getting carbon dioxide. Understood? So you have to be like you have to check the question that what electrode they are using. If written platinum electrode, then oxygen going on. Okay, no issue. Or chlorine or other thing. But if the electrode giving carbon or zinc or copper, they will react with oxygen. Clear or not?
Yes, sir.
Okay, understood. Any doubt?
No, sir.
Okay, next extra potential, third factor. If you add extra voltage, okay, then also some other reactions can be done. Okay, some other reaction like kinetically controlled reactions will be formed. Okay, then some other product we will get. Clear or not? Clear?
Yes.
Okay, now coming to second law of Faraday. Now coming to second law of Faraday. Now, what is the second law? Just give me a second. Let me draw it. Okay, now let's suppose three different solution I took. Okay, three different solution I took. And let's suppose here is copper 2 plus sulfur is there, here silver is there, and here iron plus is there. Okay, Fe2 plus is there. And they are connected to each other in a series. Okay, let's suppose this is connected. Let's suppose this is connected with this is connected with this, and this is again connected with this, and they all are connected in a battery. Okay, so what is second law? He told now some amount will deposit here after electrolysis, some amount will deposit here, some amount will deposit here, some amount will deposit here. Yes or no?
Yes.
Okay,
Yes.
now Faraday told that whatever amount deposited, let's suppose here some amount deposited W1, here some amount deposited W2, here some amount deposited W3. Faraday told that W1 by equivalent weight of first copper, okay, E1 will be equal to W2 by E2 will be equal to W3 by E3. That means this ratio, okay, this ratio should be same. So what is the second law of Faraday? Second law of Faraday told when same quantity of electricity is passed through different electrolytes, okay, different electrolytes we took, okay, and they are connected, when they are connected in a series, the weight of different substances liberated at the electrodes are directly proportional to their electrovalent weight. That means the simple thing, weight directly proportional to E, or W by E equal to constant. Okay, W by E equal to constant. Understood? Yes or no? Now you will tell, sir, E already you told, but we can't understood. So remember this thing, equivalent weight E. E is equals to atomic mass divided by the N, divided by N. N means you know N how to calculate by from seeing a reaction. N you know how to calculate. Or sometimes E is equals to atomic mass divided by valency. Okay, valency of the atom. Okay, clear or not?
Yes.
Understood. So so this is the thing. So W1 by W2, E1 by E2, that questions will come. Okay, so one question. Should I give one question?
Yes.
Tell. Question is, how much charge? How much charge required for reduction of 1 mole of Al3 plus to Al? L. How much charge required for 1 mole of Al3 plus to Al? Tell. Understood what I am asking? Yes or no? Already you told that in exam, in school it is already done. What is the problem? Acha, how much charge in Coulomb?
9 sir.
No. How 9Q? Acha, simply listen. Al3 plus 2 Al. How much electron I need? 3 electron. Yes or no? So one aluminum ion I can want to convert. I need 3 electron. 1 mole aluminum ion I wanted to convert. How many electron I need? 3 mole electron. Yes or no? Yes or no?
Yes.
1 mole of electron have how much charge? 1 Faraday. 3 mole of electron will have how much charge? 3 Faraday. Acha, 1 Faraday into Coulomb. How to convert? 3 into 96500 Coulomb per mole. So overall value you calculate around 289.289455 will come. Okay. Just you have to tell 3A. Okay. Understood? Tell yes or no.
Yes.
So it should be a revision. What is the problem then? This thing done or not? And if I will tell you this is an NCERT question, what I took now, this is a NCERT question. Simple. Okay. Clear? Yes or no?
Yes.
Mm, One question last. Question is, if a current of 0.5 ampere flows through a metallic wire for 2 hours, then how many electrons would flow through the wire? Tell. This one, another question. Another question, calculate the time required to deposit 1.27 gram of copper at cathode when a current of 2 ampere was passed through the solution of copper sulfate. Clear? Go ahead. 2 questions, then we will end. Understood 2 questions?
Yes, sir.
Okay, go ahead. Let's see who can tell. Sarvesh can tell, or Asmita or Aditya.
For first one, this is 22.5 into 10 to the power 22.
First one is 22.5 into 10 power 22. Okay. Next one. Correct one. Next one.
Next one to insert.
First one is 22.5 into 10 power 22. I think so.
2.2.
2.25 should. Okay. 22.5 will not. Then calculation mistake you did. Chemistry wise you okay, but calculation mistake.
second one is 0.026.
Second one,
0.026.
wrong. Check. So first one, how to do? If a current of 0.5 ampere flows through a metallic wire for 2 hours, then how many electron will flow? So simply Q, we need to find out, right? So Q is equals to 0.5 into 2 hours. 2 hours means 120 minutes. Yes or no? 120 minutes into second, 60. Or you can 7200 directly. You can. Okay. So I am doing like this. So finally you will get 3600. 3600 Coulomb. Yes or no?
Yes.
Now, how much, like, we need to convert it into moles? Yes or no? We need to convert it into moles. So then you convert it into mole, you will get like one electron having charge 1.67 into 10 power minus 19 Coulomb. 3600 Coulomb having how many electrons? So simple 3600 by 1.67 into 10 power minus 19. So then you calculate, you will get 2.25 into 10 power 22. Okay. Here, next, calculate the time required to deposit 1.27 gram of copper at cathodic when a current of 2 ampere was passed through it. So, to deposit 1.27 gram of copper, so M value is 1.27. Yes or no?
Yes, sir.
Acha, what is the Z value? Z value is 63.5 divided by 2.
Yes, sir.
This is E value actually. Okay. And Z by F 96500. So we know M is equals to, or you can write M is equals to Z into I into T. So T is equals to M by Z into I. So M value given 1.27. M value given 1.27 gram divided by Z value. Z is 63.5. This is gram per mole divided by 2 into 96500 coulomb per mole, and the downside ampere into 2 ampere. Okay. Sorry, ZIT. T we need, right? Oh, something we wrong. If a current through hello, 2 ampere. Okay, correct only, right? Okay, correct. So now, what will be the so coulomb we can write ampere into time. So coulomb we can write ampere into second. Okay, so ampere cut, mole inverse cut, and gram cut. That's it. So next you calculate, you will get around 965, around 1.27, and this is how much, 50? Yes or no? 50 or
0.02.
no, 965 you.
Whole 0.02 into 965.
0.02 into 96500. So 0.02 means 2 by 100, right? Into 96500. Oh, how 0.02 you are getting? Correct. 2 ampere. Correct. This value you will get. Okay. So around 2 by 100. So multiply with 2, you will get this value. Clear? Yes or no? Tell. 1920.
Yes.
Okay. 1930. 1930. Okay. So this value you will get. Clear or not?
Yes.
Yes.
Okay, so this is also this both of these are CBSE question actually. This is CBSE 17 and this is CBSE 15. Okay, board questions. So practice this NCERT questions. This Faraday's law to Faraday's law. Next day we will start. Next day almost we will complete our almost. I'll try to complete electrolytic Electrolysis. Complete this chapter. It is there one more lecture I think we need, because next day we will complete the conductance and all, and one Kohlrausch Law we will complete, and one more lecture we need for batteries. We'll try. Let's see. Next day completed, then okay. Okay. Because batteries we have to learn about corrosion and all also. Okay. Hello.
Yes, sir.
Okay. So I'll send some question. I'll send some questions on this Faraday law, on this electrolytic cell and all. Okay. So do that questions by the next day. Next class on Tuesday. Okay. Next class will be on Tuesday. Next class this Tuesday. No issue. Next class will be on Tuesday. Okay. Your vacation started?
Yes, sir.
Okay, okay. I'll take class. Actually, my vacation is not there. I'll take class after 9th May. Extra classes will be there. We will complete all the chapters. Okay.
Okay.
Any doubt?